Hello grade 7s, welcome to today's natural science video lesson. I hope you all are well. In today's lesson we'll be doing a quick recap of energy, what we've looked at so far: potential energy, kinetic energy, and the other types, heat and radiant energy. And then in conjunction with this recap, I wanted to do a revision exercise. This is topic 10 revision on page 146. Firstly, we'll look at potential energy. If you remember, potential energy has the ability to do something, but hasn't as yet been converted. It's split into three categories. Gravitational potential energy. This is when we raise an object above the Earth's surface, and the higher we raise it, the harder it falls once it's released. Now, this energy, potential energy, gets more and more, but it hasn't yet been converted, it hasn't yet been released. Once the object is released, it gets converted to kinetic energy. Next, we have chemical potential energy, and the two main examples that we looked at were food, which is the chemical potential energy in biological organisms. This food is broken down to release energy for the processes, the life processes in biological organisms. Then we have the other type, which is the electric cell or batteries, and the chemical potential energy is converted to electrical energy once the battery is hooked up to a circuit. Lastly, we have elastic potential energy. We looked at the example of the rubber band and the spring, and we said the more we stretched the rubber band, the more potential energy we gave it, and once we released it, the further it would fly. Similarly with the spring, the more we compress it, the more elastic potential energy it gets, and the further it releases, or the more energy it gives when it releases. Next up, we spoke about kinetic energy. This is the energy in a moving object, the energy of motion. This depends on two things: the mass and the speed of the object. So if an object has a very high speed, for example, a speeding bullet, it has very high destructive potential, very high energy. For the mass, we can compare rolling a bowling ball versus rolling a beach ball. And the heavier object, the bowling ball, has a lot more kinetic energy than the lighter object, the beach ball. The other main types of energy we looked at are listed here. We've got heat energy. Heat energy can come from friction. So for example, if you rub your hands together, they get warm. Can also come from combustion. That's when we burn fossil fuels. For example, in the coal-fired power station, when coal is burned, it releases a fair amount of thermal energy. Heat energy also comes from nuclear reactions. That releases a great deal of thermal energy. So think of a nuclear bomb, for example. Heat energy can also come from radiant energy waves. That's when the waves strike a surface. Next, we have electrical energy. And if you remember, electricity is the flow of electrons. So you can compare it to the flow of water through a pipe. And here our electrical wires are like our pipes, and the electrons flow through. Electrical energy can come from batteries or generators. Lastly, we have radiant energy waves. The two types we looked at were sunlight and microwaves. Now, sunlight is a relatively low frequency wave, and you can see from the picture here, the wave is relatively spread out. And if this wave strikes a surface, it gets warm. So if you stand in the sun, you get warm. The high intensity radiant energy, an example would be a microwave. So high frequency means the waves are compressed together like this, and if you put food in a microwave and these waves strikes, it gets relatively hot. Now we're going to go through some questions. This is topic 10 revision on page 146. So if you haven't done these questions, maybe pause the video, try doing them on your own, and then check for the answers. To start off, we'll look at the science language activity. It says complete the following paragraph by filling in the missing words. So I'm going to go through this with you verbally. Starts off, when a weightlifter lifts a weight, the chemical potential energy, the food energy stored in his body, makes it possible for him to lift the weight. When the weight is lifted above his head, it has gravitational potential energy. Remember, the weight is lifted above the ground. If he slips and lets go of the weight, it will fall and therefore gain kinetic energy, and that makes it land on the ground again. If the weight plates are covered in rubber, remember rubber is flexible, the weights will not crush the floor but will bounce up and down because of the elastic potential energy in the rubber. Rubber is like an elastic band, a rubber band. The weightlifter activity illustrates the law of conservation of energy, which states that, and you can look up the definition for conservation of energy, energy cannot be created or destroyed, but only transformed from one form to another, or transferred from one system to another. So all the energy that the weightlifter put into lifting up this weight and dropping it shows conversion of energy. The unit for measuring the energy of the weight is the joule, or the kilojoule if it's measured in thousands of joules. Now we move on to the test yourself part of this revision exercise. Test yourself question 1 asks us to differentiate between kinetic energy and potential energy. So here you can't simply just put the definitions of kinetic and potential energy. You have to differentiate, or in other words, compare them. So we know that kinetic energy is the energy in a moving object, and potential energy is the energy the object has when it's at rest. So for example, when we stretch the rubber band, it's at rest and it has elastic potential energy until it's released. Next, question 2 asks us to explain using an example why energy cannot be created or destroyed. That's our law of conservation of energy. The example I've used here is when we put petrol in a car, the car moves, it's used up in the car until all the fuel is finished. And the petrol, which is a fossil fuel, has chemical potential energy that's changed into kinetic energy with the car moving, and also it creates heat energy, the engine gets hot, and sound energy, the noise the car makes. So here in this example, energy is not created or destroyed, it's just changed into different forms. The next question of the test yourself revision exercise is question 3, and it asks us to complete the following table. I've redrawn this table over here. Just take away the answers. So we have the energy system, the form of potential energy, energy input, where is the energy going, and the form of kinetic energy, the form of energy in motion. Let's look at the first item, burning coal. The form of potential energy, remember we had 3 types, chemical, gravitational, and elastic, and coal is a fossil fuel and a form of chemical potential energy. The energy input here is the fossil fuel, coal. Where's the energy going? When we burn coal, it creates thermal energy or heat energy. And is there a form of kinetic energy involved when we burn coal? Yes, there is. Whenever something is burnt or whenever there's heat, it causes air to rise. Hot air will rise. So you can see an example of this if you look at your heater at home. You can see an air shimmer above the heater. If you put a thin little piece of paper above the heater, you'll see that it moves up as the hot air moves up as a draft. So the form of kinetic energy is the air movement upwards. The next item we'll look at is an electric fan. So for the form of potential energy, you might be tempted to put down electrical energy, but that is not a form of potential energy. Remember, we have the three categories: chemical, elastic, and gravitational. Now, the energy, the electricity used to power the fan comes from some type of potential energy. So if you think of a coal-fired power station, coal is the input, and that's a form of chemical potential energy, or this fan could be powered by a battery, which is another type of chemical potential energy. What is the energy input? It's electricity. Where is the energy going? It's going to the motor. So remember, a motor takes in electrical energy and spins, gives kinetic energy out. So the form of kinetic energy is when the motor spins and causes the blades of the fan to spin. The last item we'll look at is a person blowing a vuvuzela. What is the form of potential energy? Well, it's the food energy in the person being converted to muscular contractions. When a person exhales, the food energy is converted to kinetic energy. So the form of potential energy is chemical. The energy input is the person. The energy is going to the vuvuzela. And the form of kinetic energy is sound. So when a sound is actually vibrations through the air movement, and remember, movement is related to kinetic energy. The last question, question 4, is another table. We have a column which lists the various energy systems: mechanical, electrical, biological, and thermal. We asked to give examples of each and the type of energy that's used in each. So by used, it means what the user is getting out. For a mechanical system, we can think of riding a bicycle, and the user is gaining kinetic energy. For an electrical system, we can think of a radio, and the user is getting sound energy. A biological system, we can think of eating a sandwich, the user would then be gaining chemical potential energy or food energy. Lastly, for thermal energy, we can think of taking a hot bath, and the user would be gaining heat energy or thermal energy. So that concludes today's video lesson. I hope you understood the theory and the questions. If you're struggling to understand, please message me, and next time we'll be continuing, as in the textbook, with heat systems, convection, and conduction. Thanks for watching, and take care.